What would you do if you were to see a problem like this? What is the answer? So this represents summation. You probably heard of the expression sigma notation. When you see this funny looking E symbol, it's basically tell you to find the sum of something. Now what we're going to do is we're going to write out some numbers starting from 1 ending to 5 using this expression n squared. So when n is 1, we're going to have 1 squared. And since we're taking the sum, we're going to put a plus. And then when n is 2, we're going to have 2 squared. And we're going to continue this all the way to 5. So this expression is telling us to take the sum of n squared from 1 to 5. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And now we just got to add the numbers. 1 plus 9 is 10. If we combine 4 and 16, that's 20. And 10 plus 20 is 30. 30 plus 25 is 55. So that's the value of this expression. So now let's work on some other similar problems. So let's say we want to find the sum of 2 raised to the n from n equal 1 to, let's go to 6 this time. Feel free to pause the video if you want to try this problem. So first, let's replace n with 1. So it's going to be 2 to the first power, and then we're going to replace n with 2. And then it's going to be plus 2 to the third, 2 to the fourth, all the way to 2 to the sixth. And then we just need to perform the operation. So 2 squared is 4, 2 to the third power. If you multiply 2 3 times, 2 times 2 times 2, that's 8. 2 to the fourth power is 16. And then each number is just 2 times the previous number. So 2 plus 8 is 10, 4 plus 16 is 20, 32 plus 64 is 96. 10 and 20 is 30, 30 plus 96 is 126. So that's the value of this expression. Now let's work on some other example problems. Consider this expression. We want to find a summation of 3n plus 2 from n equal 1 to n equal 5. Go ahead and try that. Replacing n with 1, we're going to have 3 times 1 plus 2, which is 5. Now, if we replace n with 2, it's going to be 3 times 2 plus 2, so that's 8. When n is 3, it's 3 times 3, which is 9, plus 2, that's 11. And at this point, we can see a pattern. What we have is an arithmetic sequence with a common difference of 3, because the numbers increase by 3. When n is 5, the value of 3n plus 2 will be 17. So we just need to add these 5 numbers. So you could use a calculator for this if you want to. 5 plus 8 plus 11 plus 14 plus 17. This is equal to 55. Now, because this is an arithmetic sequence, we can also use another formula to calculate the sum. The partial sum of an arithmetic sequence is s sub n is equal to the first term plus the last term divided by 2. So basically it's the average of the first and last terms times the number of terms. So we want to find the sum of the first 5 terms. This is the first term, a sub 1. This is the second term. And this is the last term, a sub 5. So the value of the first term is 5. The value of the last term is 17. And the number of terms, there's 5 terms in that sequence. So 5 plus 17, that's 22. 22 divided by 2 is 11. So 11 is the average of the first and the last term. So we just got to take the average and then multiply by 5. And we're going to get the sum of the sequence, which is 55. Now, why is that important? Here's why. Sometimes you might be given a problem that looks like this. You may have to find a sum to a very large number. You don't want to take the time to add 100 terms. because that's just going to be too time consuming. Instead, you want to use that formula because it can help you get the answer quickly. So let's write out a few numbers. When n is 1, 4 times 1 plus 5 is 9. When n is 2, 4 times 2 is 8 plus 5 is 13. When n is 3, 4 times 3 is 12 plus 5, that's 17. So we can see that the common difference is the number in front of n, which is 4. Now this is going to continue. We don't want to do this 100 times, but we do want to find the last term, the 100th term. And there's a formula that can help us define it. To find the nth term in an arithmetic sequence, it's a sub n is equal to a sub 1 plus n minus 1 times d. We have the first term. We know what the common difference is. The common difference is 4, since the second term is 4 units higher than the first term. And each successive term is always going to be 4 units higher than the previous term. So d is 4. And thus we have to just plug in or replace n for 100 to get the 100th term. So the first term is 9, n is 100, the common difference is 4. 100 minus 1 is 99. 99 times 4 is 396. To get that, you could do 4 times 100, which is 400, and then minus 4, you get 396. 9 plus 396, that's going to be 405. So the last term, the 100th term in this sequence, is 405. Now that we have the first and the last term, we could use the partial sums formula to get the answer. So the sum of the first 100 terms is going to be the first term, which is 9, plus the last term, which is 405, divided by 2, times n, which is 100 terms. So let's take the average of 9 and 405. The average of the first term and the last term, if you add 9 and 405 and then divide it by 2, that's 207. So we're going to take that average, multiply it by 100, or the number of terms, and that's going to give us the answer. So it's 20,700. This is going to be the sum of the first 100 terms. Now let's work on another example. So let's say we have 3 over 2 raised to the n minus 1, and we're going to go up to 4. Try that one. When n is 1, it's going to be 3 over 2 raised to the 0 power, which is 1. When n is 2, this is going to be 2 minus 1, or 1, and so we're just going to get 3 over 2. When n is 3, this is going to be 3 over 2 raised to the 3 minus 1, which is 3 over 2 to the second power. 3 squared is 9, 2 squared is 4. When n is 4, we're going to have this. 3 to the third power is 27. 2 to the third power is 8. So let's add up these numbers. I'm definitely going to use a calculator here. So 1 plus 3 over 2 plus 9 over 4 plus 27 over 8. This is equal to 65 over 8. And as a decimal, that's 8.125. Now what we have here is something known as a geometric sequence. To go from the first term to the second term, we need to multiply by something known as the common ratio. The common ratio in this example is 3 over 2. If you multiply 1 by 3 over 2, you're going to get 3 over 2. If you multiply 3 over 2 by 3 over 2, you're going to get 9 over 4, and so forth. And so whenever you have a geometric sequence, you need to multiply by some value to get the next term. So let me just help you to distinguish an arithmetic sequence from a geometric sequence. So this is an arithmetic sequence because you need to add by some common difference to get to the next term. In this case, the common difference is 3. This is a geometric sequence because you need to multiply by a common ratio to get the next one. In this case, 2 is the common ratio. Now, there is a formula that can help us to calculate the sum of a finite amount of terms in a geometric sequence. And that's it. So in this example, we want to find the sum of the first 4 terms. So we want to calculate a partial sums as opposed to an infinite sum. The first term is 1. The common ratio is 3/2. And n is 4. So we're going to raise this to the 4th power. On the bottom, it's going to be 1 minus 3/2. So this is going to require some math. Well, we could ignore this one. It's not going to change our answer. 3 to the 4th power, that's 81. 2 to the 4th power is 16. 1 minus 3/2, well, we can replace 1 with 2/2. And the 1 on top, we can replace that with 16/16. 2/2 minus 3/2 is negative 1/2. And 16 minus 81, that is negative 65. So I have negative 65/16 divided by negative 1/2. Now what I'm going to do is multiply, well, we can cancel the negative sign. 2 negatives divided by each other is going to give us a positive number. But I'm going to multiply the top and the bottom by 16. So these numbers will cancel. Thus I'm going to get 65 on top. And then 1/2 times 16, half of 16 is 8. So thus I get the same answer, 65/8. So that's how you can calculate the partial sums of a geometric sequence. Because if this were to go to 100, you certainly want to use this formula. Now let's try one more example. So this time, instead of going to a finite number, we're going to go to infinity. And let's say the formula is 8 times 2/3 raised to the n minus 1. Now let's just plug in a few numbers just to have a sequence. When n is 1, the exponent is 0. 2/3 raised to the 0 power is 1 times the 8 in front of it. When n is 1, it's going to be 2/3 times 8. So we're going to multiply this number by 2/3. 8 times 2/3 is 16/3. And then if we multiply 16/3 by 2/3, we're going to get 32/9. So for the numerator, we're going to multiply it by 2, but for the denominator, let me say that again. For the denominator, we're going to multiply it by 3. The next one is going to be 128/81, and so forth. Now, this is going to go on forever. And so it's impractical for us to calculate it by hand. We need to use a formula. This is what is known as an infinite geometric sequence. To calculate the sum of an infinite geometric sequence, it's simply the first term divided by 1 minus r. Now, this formula works if r, that is the absolute value of r, if it's less than 1. If r is greater than 1, the sequence is going to continue to increase. It's going to get bigger and bigger. So it's not going to converge to a finite sum. But when r is less than 1, the numbers are getting smaller and smaller and smaller. And so the sum is going to converge to a number eventually. If we were to get the decimal values of these numbers in a sequence, you could see that each successive number is less than the previous number. (64/27) is approximately 2.37. And so the numbers are getting smaller and smaller. When that happens, the sum will converge. For the most part, it will most likely converge to a specific value as n goes to infinity. But to get the answer for this problem, all we need to do is simply plug in the first term and the common ratio into that formula, and we're going to get it. The first term is 8. The second term, the common ratio rather, is 2/3. Now let's replace 1 with 3/3. 3/3 minus 2/3 is 1/3. And to simplify this, we need to multiply the top and the bottom by 3. 1/3 times 3 is 1, so we just get 8 times 3, which is 24. And that is the sum of the geometric sequence. If you were to continue this list and you were to add all these numbers, you'll find that the sum will converge to 24. As you add each number in the sequence, you're going to get closer and closer and closer to 24. So that's it for this video. So now you know how to evaluate functions when it's presented in summation notation.